Welcome to the Advances in Research and Innovation stream of SNOMED CT Expo 2023. My name is Victor Medina and I'm a surgical terminologist at SNOMED International. I will be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A button to type your questions to the presenter. On-site attendees, please use the microphone provided in the room. I'm now pleased to introduce Stefan Schulz from Medical University of Graz, who will be presenting the need for standards-based annotation guidelines in times of large language models. Stefan, please proceed. We will compensate the time afterwards.
Yeah. Okay, thank you very much. I'm sorry for the delay. I think I'm preaching to the choir when I mention that EHR are really dominated by clinical narratives, which come in all kinds of shapes and forms, which are compact, sloppy, idiosyncratic, because they are meant for human to human, or better, expert to expert, clinician to clinician communication. But whenever we want to use them for machine processing, we have major interoperability bottlenecks. On the other hand, I think I'm also here in the right place just to remind you and what you already know, namely that semantic standards as we know them, SNOMED, CT, and FHIR, are very fine, but nevertheless they allow multiple equivalent representations, such as here you see something like suspected gallstones. You can encode it as a pre-coordinated concept, but also you can use post-coordination, you can use SNOMED only, you can combine SNOMED with FHIR, or you can have a complicated description logics representation for the same thing. And in some cases, logic helps us to bring the different meanings or the same meanings with different surface representations together, but not always. Yeah, I think that most people here share the desideratum that we should eventually come up with a normalized, computable representation based on interoperability standards, which then also enable us to go from unstructured EHR content to structured content, and ideally in a kind of what we could name a clinical knowledge graph, which is oriented along models of meaning, such as ontologies like SNOMED CT, together with models of use, such as given by HL7 FHIR. And of course, we have here a toolbox called NLP, or natural language processing. And and this toolbox is getting really full and full by fancy tools and resources, particularly in what we have witnessed over the last 1-2 years with large language models, which still fascinate all of us and perhaps are just the first step of a long way. But nevertheless, NLP is also, or NLP includes also classical methods like pipelines, using rules, using lexicons. It includes classical machine learning, such as SVMs or random forests and so on. But really the fancy stuff is everything around neural networks, deep learning based on transformer technology, all of those famous large language models. And if we look at things like that, I wouldn't have, and I think many of you wouldn't have thought that it's so easy, for instance, to feed extremely abbreviated and telegram style, and sometimes also wrongly written chunk of clinical text into a machine, which then provides you with a nice table of short forms and long forms, with often, I would say, an accuracy of more than 90%, but this is still subject to evaluation. But this so far is just setting the stage for what I'm talking about, namely annotation of clinical text. Manual annotated clinical text corpora are a fundamental resource for NLP research and implementation. Although non-annotated corpora also recently have played an extremely important role. But nevertheless, you also need annotated corpora for two purposes. One purpose is training and the fine-tuning of language models. And the other equally important purpose is to benchmark NLP processes and to be able to measure really how well an NLP process really preserves the original meaning, which is fundamental when it is about decision-making, patient safety, and so on. But manual annotation needs to be driven by guidelines. And guidelines need to consider the intended target representation. You can only formulate annotation guidelines if you have a clear concept of what should be the outcome of the annotation process. For instance, as a target representation, we have in mind a certain design of a knowledge graph, and therefore the annotations should also end up in a kind of annotation graph. For here we have nodes which represent codes, SNOMED CT codes or literals, and we have links that represent semantic relations between nodes. Manual annotation is a well-known knowledge acquisition bottleneck because it requires domain expertise, extensive training. Sometimes annotation is a bit not very exciting exercise, and so you need to keep the annotators motivated. And nevertheless, you find sometimes a large variability between the results between annotators. You have the phenomenon of annotation fatigue, that in the beginning they annotate very correctly, but more and more hours they do nothing but that, then they get tired and the quality of the annotations goes down. Then, of course, they have to deal with ambiguities. And if you look at texts as the one I showed you, it's a general problem that clinical texts are full of short forms, of acronyms, so that you don't know whether, for instance, RA means rheumatoid arthritis or right atrium or ATR. No, what? Anyway, RTA, renal tubular acidosis, or road traffic accident, and just to name a few famous examples. So, as a success factor, of course, first of all, you need good tooling, but also good training. You need to have repeated training sessions. And if you look at the graph at the right-hand side, you see that you need a long way until really you go to production. You need to develop guidelines. You have to test them. You have to update them iteratively. You have to be very close to the annotators in the beginning, and only after the annotators having a certain degree of routine and the guidelines are more or less consolidated, then you can really expect a significant production. But you need to have adjudication between the annotators. You need repetitive quality checks by measuring inter-annotator agreement. You need to establish good communication channels. And first of all, you need rigorous annotation guidelines. And this is now, what we found out is that the best annotators are medical students. Clinicians normally too occupied by other important tasks. And frankly, if I were patient. I don't want to be treated by a physician who thinks more about annotation than about my health. So I think that medical students, probably it's a shared experience of those of you who also have worked with manual annotations, that medical students, especially when you pay them and perhaps you offer them some possibility to contribute or to participate in research projects, are very thankful persons for this task. So I'm gonna talk now about annotation, our annotation guideline. Not forgetting just to also mention the tooling. So let me just start with the tooling. We use annotation editor called Inception, developed by the University of Darmstadt in Germany. And we currently use it into large projects, a German one called Gemtex and a European one called IDAVA. But I'm now focusing on the annotation guideline itself, which is called Annotation Guideline for Semantic Annotations of Clinical Narratives based on SNOMED, CT, and FHIR. And regarding this annotation guideline, we make a distinction between general annotation principles this guideline propagates and specific principles which really depend on the underlying standards. Starting with the general principles. So one principle is that we perform only semantic annotation. So we do not care about part of speech and articulations, etc. Then we annotate on two levels. On the one hand, we annotate text spans, entities with codes and literals. The codes are codes from a terminology. And the next level is binary relation with user-friendly predicates. It's very important to hide the complexity of, let's say, the internal wiring of ontologies like SNOMED or information models like FHIR from the users, so from the annotators. So it should be as user-friendly as possible. And then all the vocabulary should be linked to ontology-based standards. They should be multilingual, well-curated, ideally free or free for research like SNOMED CT, ontology-based, compositional. And this annotation vocabulary determines the annotation spans, which may go from subword character sequences to multi-word n-grams with the preference of the longest match. And this is given by the vocabulary and not by a named entity recognition step beforehand. And then we annotate close to text so that the annotators should just annotate what's written. They should not interpret what is written, because this is really a slippery slope and may cost a lot of time and not really bring a real benefit. The interpretation is still the challenge for who uses the final result. Yeah, and now specific annotation principles regarding SNOMED and FHIR. So we distinguish between the core hierarchies, which are those here, clinical finding and so on, which are characterized by a higher proportion of sufficiently defined concepts, and the so-called supportive hierarchies, as given here, which are mostly characterized by primitive concepts, but not to forget also relevant HL7 FHIR value sets mapped to SNOMED concepts. Yeah, of course, we could also keep them as they are, but it's easier for the annotators if they have only one vocabulary, namely SNOMED. Yeah, and then the annotation predicates, the binary relations, link core concepts to supportive concepts, such as, for instance, fracture of the wrist to laterality left. This would be a typical case of linking a core concept to a supportive concept. And these predicates are grounded in SNOMED object properties or chains of SNOMED object properties, but also relational chains of fire elements, and maybe also in some cases also both, because we know that, for instance, something like family history can be expressed in the family history resource of fire, but it can also be represented in the situation hierarchy of SNOMED. And so if on the surface we have just a very simple predicate like in family, then in the background we can map this even redundantly to a post-coordinated expression along the SNOMED concept model for the situation hierarchy, but also to instantiation of fire resource. So this is just an example for this. There are three predicates, and the annotators are happy to have these simple predicates, for instance, for the site of a finding or event or procedure, so they don't need to distinguish, for instance, between finding site and procedure site, because it's clear from the context what is meant, or not caring about whether they use condition body site this as a slot in the condition resource of fire, or whether they should use post-coordination pattern using the SNOMED relation finding site. They just annotate a finding, they annotate an anatomical site, and then they link the both using site direct. And similar in family, as you see also where there are but semantically most equivalent representations. The red one is fire, the blue one is SNOMED, or also verification status, which is one of the most fundamental things which is indispensable to distinguish between, for instance, a finding which exists and the finding which is only suspected or which does not exist. So some example here, the two-level annotation. Yellow, the text spans annotated with codes, with SNOMED codes or with literals, such as, for instance, a date. And the green level shows the links between these yellow annotations. Then what is meant by deep annotation is that really the annotations exploit the whole depth of the vocabulary and not just an entity type annotation. There were in the past a lot of annotation challenges which really limited themselves just to annotating something with drug, procedure, disorder, etc. This is not meant here. We have annotation vocabulary which contains the concept conjunctivitis of right eye, and therefore we annotate, we use it. We do not just annotate it with disorder. Yeah, then this already mentioned longest match principle, so that the annotation spans are determined by the annotation vocabulary. And this really reflects also the granularity of SNOMED. For instance, SNOMED has a code for open fracture of femur, but not open fracture of thumb structure or thumb. So for whatsoever reason, in the first case, of course, we have this code and then we annotate the whole thing. In the second case, of course, it's very similar. It's just the thumb instead of the femur, but exposed fracture of the femur of the thumb is not pre-coordinated. So we have to use two codes and relate them by predicate site. Yeah, and then only annotate what's explicitly stated. For instance, here headache following brain concussion. Here you just annotate after, because it is not clear whether this is really due to. So you should not, or annotators should not waste their brain power reasoning of whether this is due to or after. It's not stated that it's due to, it's stated that it's after brain concussion, and so annotated after brain concussion. And then this is important because sometimes you get the impression also here in this conference and talking about terminology that there are only concepts, forgetting that what concepts are types or entities of meaning which are instantiated by real things. So if we have here a sentence such as sarcoma was diagnosed, the tumor, etc., 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 we talk about one thing. We do not talk about a sarcoma and the neoplasm. We talk about one instance, which is a sarcoma, and then the next sentence talks about this sarcoma, and it's just a very common pattern of speech that you don't repeat the same term, but sometimes a more general term. This is called nominal anaphora, and this is also something we have to annotate because this patient has exactly one tumor and not two tumors, one of which is just a tumor, the other one is a sarcoma. So this brings us just to one thing I just scratched at the surface, which we should bear in mind when we talk about a final, let's say, standardized, normalized, or canonical representation of content of a clinical document. Of course, we have the text level, and for instance, suspected breast cancer might look at just a specialization of diagnosis breast cancer. But you have to look at the details. And this is then very important regarding the processing downstream of the annotations, be they manual annotations or machine annotations by model trained by annotated corpora. So you have here, for instance, in suspected breast cancer, can I point? Yeah, you see, you have just a concept. I have to point, yeah, you have just a concept. Why don't you have an instance of this concept? Because you don't know whether there is an instance. And perhaps you want to, if you have the final representation of this patient, you want to know whether there is a breast cancer or not, or you want just to count in a cohort of patients dosed with breast cancer, and suspected breast cancer does not imply the instance of a breast cancer, but here diagnosis breast cancer, it would here, or confirmed diagnosis would be more precise, would here allow to instantiate this concept. Okay? And therefore the instances are also important here. They should not be forgotten. Yeah, and also if you have something like mother breast cancer, it goes to a different part of the knowledge graph, because here you have to instantiate family member history. Yeah, here you instantiate a resource condition which relates to this patient. Yeah, but this here relates to another patient. So that means, on the one hand, the annotations and the annotation guidelines look quite straightforward, but then the more complicated thing is then how you really process a kind of annotation graph in order to become a knowledge graph which really represents the meaning of the text that had been analyzed. So let me conclude. Annotated corpora are essential for NLP training and benchmarking. So you need ontologies, you need terminologies for representing the entities of language, and you need information models as instance level templates, but they need to be linked to ontologies. So it's very important that these information models refer to, for instance, SNOMED codes. Nevertheless, clinical text annotation is challenging and very time consuming because of the importance of detail in annotation guidelines. And therefore you need good tooling And it's very helpful, but we have found out with our annotators that you need an intuitive set of predicates. And what then happens after the assertion of these predicates behind the scenes is not of interest for the annotators. So you should really shield the annotators from the complexity of an ontology or an information model. So what we are working on currently is that we want to speed up the annotation process by pre-annotating the text by existing NLP systems in a way that then when the annotators open the document in this inception tool, that they have large parts of text spans already annotated, but of course they have to check them and maybe correct them. And also what we are preparing currently is an inter-annotate agreement experiment, because we see also a good inter-annotate agreement as an indicator for the quality of the guideline and the training process. So this annotation guideline, and this is perhaps the most important here in this talk, this annotation guideline is open for comment, for cooperation, for reuse. The more people look at this document, the better, the more feedback we get, and it's really open for everybody. Yeah, its development is currently supported by 2 grants, and there are a lot of people. We are very thankful for their contribution, and so I would be very happy also in the future to count on some of you to contribute and perhaps even to use this guideline. Thank you very much.
Thank you, Stefan. We have time just for one question. That's a reminder, if you're in the room, please use the microphone in the central aisle. Is there any question in the room? Just one.
Thank you very much, Stefan. This was very inspiring. So you talked about you have the model and you have the FIRE model and you have the terminology. Mm-hmm. And there is a well-known phenomenon of semantic overlap.
Yeah.
And could you reflect a little bit on how would you prioritize cases where you have a semantic overlap?
Yeah, I can just go back to this here. Yeah, look, for instance, in this in family. Yeah, at the level of the annotation, you don't need to care. Yeah, you have, and this is a reason why we give the annotators just this predicate in family. So, for instance, diabetes mellitus type 2 in family, grandfather, something like that. That's sufficient. And under the hood, you have 2 ways to represent it. One is FIRE. The red thing is FIRE, and this is SNOMED. And of course, you could wait perhaps for many, many years until the 2 standard bodies agree on a clear boundary. Yeah, I remember, I think it was more than 10 years ago, I studied that so-called term info document and gave a presentation on it. And so it's extremely complicated. So, but it's better not to wait, but just to model it redundantly. And if you just then translate it once in this pattern and once in that pattern, then then both communities are happy. Those who want to query it only using SNOMED and the other one using FIRE. So I hope this is the answer to the question.
Thank you, Stefan. And with that, we will conclude this session. Thank you. And this is for you, Stefan.
Oh,